Today our lesson is talking about parallel circuit. In this lesson, we are going to talk about what is the parallel and what is the difference between the series and the parallel circuit. Now, in the previous lesson, we said that the circuits have two types, series and parallel. The series, when the resistors are connected in one path, but the parallel here, if the resistor now, or if we have more than one wire and we have more than one path for the current. So this was the series, this is the series, and this is the parallel circuit. As you see in the first picture here, we have the series. We have two lamps that they are connected in series. So we have only one path for the circuit. This was a series circuit. But if you look at the second circuit here, we have two lamps. If you look at the current now, the current has two paths. It could have this path and it could have this path. So here now the current, when it is come out from the battery, it could enter here or here. So here we have two paths for the currents. Since we have two paths, that's mean this type of circuit we called it parallel. But here we have only one path for the circuit. So one path, it's mean series. More than one path, we called it parallel. This is now here the circuits. So far we talked about the series in the previous lesson, and we said the series circuit is the electrical circuit that is arranged in equal or sequence. As we said, here we have three resistors that they are arranged in equal or in sequence, or the circuit has only one path. And you said that the disadvantage of the series was if one lamp dropped in the series, then the other lights go out, as we see on the as we saw on the YouTube video. And flame lights without each other is not as obvious, and the further from the power source, increasingly dim lights. The most important for you here, the first one, that if one lamp removed, then the other lights go out. But the advantage from the series circuit, that's cost effective. That's, as you know, which is have more, which one can I save my money? If I have one wire and I connect the three lamps, or if I have three wires and I connect the three lamps, which one is the cost effective for me? The first one with one wire is it has a less cost than if we have three wires. So the advantage from the series is how to save the wiring and also the switch, the key. For the series, I need only one key, open or close them. But for the parallel, I need for each lamp now, I need three keys, or three keys, or three switches. So for the parallel, I need three different switches with three different wires. So it has more cost than if I am in series. Let's now start with the parallel. The parallel, it's an electric circuit with more than one path for the current. So as you see here, we have three lamps. They are connected in parallel. They are not connected in a sequence in the same line in three or in different lines. These lines are parallel to each other. Now, from where we take the parallel, did you remember in math when we have, as an example, this shape, and we say that this line is parallel to this line? Meaning of parallel, that they are coming up to each other. Here also in the circuit, parallel circuit, that means we have 3 lamps, and these 3 lamps are parallel to each other. They are up to each other. This is how it will be. In our real life, it's come like this. Look at this picture here. Here we have the battery. Here we have 1 lamp and 2 lamps. The currents coming here, it could have this path or this path. To draw it now in circuit, to draw it now as a schematic circuit, this is the battery, this is the first resistor, and this is now the second resistor. This is a parallel circuit. Parallel, it's like parallel sides in math. The resistors are parallel to each other. The series, they are sequence. They have the same path. If I have only one path, we call it series. More than one path, we call it parallel. But here now, if as an example, this light goes out, it doesn't work. What did we can the other lamps can work? Yes. This is the advantage of the parallel. If one lamp goes out, if one lamp is not working, that means the other lamps can work. But in the series, as you see in the previous example in the previous week, if one light is going out, if one light is not working, all the other lights will not work. The example for the parallel is our home. In our home, if you turn off the kitchen as an example, that means you didn't turn off the living room, because they are not connecting in parallel in the series. In series, that means when you I'm sorry, let's come back. Did you hear me? So, series, that's mean if you switch off or turn off the switch in the kitchen, that means you disconnect or you turn off the all lamps in home. This is the meaning of series. But they are connected in parallel. What does it mean? That means if you switch off the kitchen, that means you didn't switch off the living room. You didn't switch off their bedroom. So one of the examples for the parallel is our home. Now, let's see here. This is the series and this is the parallel circuit. The series circuit, as you see, we have this is the battery, and they are connected in one. The 2 lamps are connected in one path. But here they have 2 paths, 2 wires that they are parallel to each other. So this is the parallel circuit. So the parallel circuit, it means that they are arranged in rows. So we have branches in the circuit. They are arranged in row. The first one, they are arranged in sequence. This, they are arranged in row. How we draw them? As we see here. We have the voltage, or the voltage source, we can say. This is here the voltage source. Now here we have 3 resistance or 3 lamps. This is the first one, second one, and the third one. Now, from here, we have the current, but the current, when it's stopped at this point, they see to which branch should I go? Since they want to make the 3 resistors are working, they have to go to each branch. So they have to go R1 and to R2 and to R3. If they are go to the R1, we call it I1. And if they are going in R2, we call it I2. And if they are going in R3, we call it I3. As an example, if it is 6 ampere, So here we have 2 ampere, 2 ampere, 2 ampere. When they are divided into equal currents, if the resistance are equal. If the resistance are equal, so the current will be distributed in 3 paths, 2 and 2 and 2. And when they are going out here, they are coming back as 6 ampere. So in the series, we say that the current will stay the same at any point. But in parallel, no. Here we have current divider. So in the parallel, the current now are divided or are distributed. But in the series, the voltage are distributed. So here, so if we have series and if we have parallel, on the series here, the resistance are connected in sequence. This is R1, this is R2, and this is R3. In parallel, they are connected in row. R1, R2, and R3. So here they are connected in row, or they are connected in sequence. Now, how will we find the total resistance? To find the total resistance in series, we say that we have to add them R1 plus R2 plus R3. But in parallel, we have to take the reciprocal of the R total will be the reciprocal of R1 plus the reciprocal of R2 plus the reciprocal of R3. So here, to find the R total, you have to say 1 over R total is 1 over R1 plus 1 over R2 plus 1 over R3. The reciprocal so the reciprocal of the total will be the reciprocal for each series, for each resistance. This is in parallel. In series, you have to add them. Now, in series, we called it voltage divider. The series are voltage divider. That means the voltage will be distributed. But the parallel, we called it current divider. Because the currents here are divided on each term. Since now here the voltage are distributed, so the current will be the same. At each point. But in the parallel here, the voltage will be the same at each point. So the voltage divider is the series and the current divider is the parallel. So if we have here this circuit now. And the current now here is going up as 10 ampere. Now, here they have the same resistance, R1 as R2 equal to R2 is equal to R3. As I told you, they are connected in parallel. So the current will be divided into the 3 paths here. We have I3, we have I2, and we have I1. So the current at each point will be different than the others. That's mean the current at this point here is 10 ampere. But the current at this point here is 3.3 ampere. But the voltage will be the same. That's mean the voltage at this point will be the same voltage at this point, will be the same voltage at this point. So the voltage here, V at any point, or you can say V1 equals V2 equals V3, the voltage for any resistance are the same, but the current is not the same. This is now for the parallel circuit. Is it clear? No.
Yes, teacher.
Yes, teacher.
Now, what is the disadvantage of the parallel? The disadvantage here, that is that we have wasteful cable and switch. You need more wires, you need more cables, more switch, so you need to pay. But the advantage for it, that if one light goes out, the other stay lit. If one lamp is not working, it didn't affect the circuit. All the other lamps can work. And the second one, we have equally bright lights. This is not very important. The most important for you, that's if one light goes out, the others stay working. So let's here summarize. This is the circuit, the series circuit, sorry. Here we have two lamps that they are connected in series. So how we draw it? We draw it like this, R1, R2, and R3. Now, in the series circuit, the electric current will be the same, as I told you. So the I total, the current total, is equal to I1, or equal I2, or equal I3, or I4, and so on. The current at any point. The voltage here will be divided. So the voltage total in series is V1 plus V2 plus V3. And the resistance here was R1 plus R2 plus R3. This is for the series circuit, but in parallel. The current here will be distributed. We call it current divider. So the current on the parallel is I1 plus I2 plus I3. Look at here and look at the difference between the here and here. On the first case here, the currents are equal, but here no. The I in parallel is I1 plus I2 plus I3. They are divided. So this is the difference between them. Now, what about the voltage? Let's compare now the voltage here. The voltage in the series, we call it voltage divider. So the voltage total will be the V1 plus V2 plus V3. But in the parallel, they are equal at any point. So V1 is equal to V2 is equal to V3. Now let's talk about the resistance now. On the resistance, the R total will be R1 plus R2 plus R3. Now RS, it's mean R in series, and RP, that's mean R in parallel. So the R total here is R1 plus R2 plus R3. You have to add all the resistance. But on the parallel, you have 1 over R1 plus 1 over R2 plus 1 over R3 will be 1 over R total. So the reciprocal of R will be the reciprocal of the first one plus the reciprocal of the second one plus the reciprocal of the third one. Is it clear?
Yes, teacher. Yes, teacher.
Yes, teacher.
Now, what is the name for a circuit that has only one path for the current to flow?
Series.
Series, exactly. Thank you. Now, what kind of circuit has more than one path for the current?
Parallel.
Parallel. As you see here, look at this one here. How many paths for this parallel circuit?
6.
6 paths. Excellent. Here we have path 1, path 2, 3, 4, 5, and 6. So here the current will go out from the battery I1, I2, I3, I4, I5, and I6. After that, they are coming back as I6, I5, then they are connected. They are grouping to come back to the battery as the I total. Now, what happens to the lights in the series circuit if one light goes off? Look at here. Imagine now one of the lights goes off. What will happen with the series circuit?
It will, all of it will not work.
Yes. All the lights go off. Look at them here. If we have broken lamp, or if I broke the first lamp here, all the lamps, either than they are working or in spite than they are working, but if one lights on them go off, all the lights will go off on the series circuit, even though they didn't have any broken filament. Now, why do all the lights go on when one light fails in a series circuit?
Because the current cannot be passed to the other light bulbs.
Yeah, because no current can flow because of the gap. There's no other path for the current. So if it's come here now, if the current now come from here, it stop. Oh, let's change the colors first. If the current is here now, when it's find this lamp is not working, because this lamp is not working, it's make a gap. It's make a disconnecting wires. It led them to stop. So if there's a gap, that's mean the current now will not work because it's make, oh, there's no path for the current to pass for the circuit. Now, what happens when one light goes out in parallel circuit now? Does it affect?
No, it does not make effect. The other will work.
So the other lights can stay on. Look at this one here. Imagine it now. Here you have now this current. It comes to work. It work. It find this one. Okay, it's not work, but it still goes out because there's a gap here. So all the lights can work. Imagine now as it like, in other words, I give you example. Like imagine now you have many rooms here. Here we have room number 1, room 2, room 3, and so on. If you come here, you find the door is open, you enter the room. The door is open, you enter the room. But you find here the door is closed, you didn't enter it. But it didn't affect the other rooms. But on the series, if you come to enter from here, and you find that the first or the and here you have, as an example, you have one door only, and here you have bed number 1, bed number 2, and bed number 3. If the door is closed, can you enter and sit on bed number 3?
No, teacher.
No, this is the meaning of series. If one doors, or sorry, if the light or the door is closed, so it will be affect all other doors or all the other beds. You cannot enter it. Let's continue now here. Now, why do the other lights stay on a parallel circuit? Because the current can still flow. It can still flow. We have many paths now. It has another path to enter it. Now let's have an example here. This is for a series circuit. If we have here R1, 15, R2 is 5, and R3 is 30. To find the R total, you have to add them. 15 plus 5 plus 30. So the R total here, is 50 ohm. This is in series. Now, what about in parallel? In parallel here, what did we have? We have them as 50, 50, and 30. To find the R total, as I told you, 1 over R total is 1 over 15 plus 1 over 15 plus 1 over 30. Then make them have the same denominator. So 2 over 30 plus 2 over 30 plus 1 over 30 is 5 over 30. This is what? 1 over R total. So 1 over R total is 5 over 30. So R total will be what?
6.
Will be, if I write the reciprocal of R total, I have to write the reciprocal of this one, which is 30 over 5, which is 6 ohm. So when you write the reciprocal for this 1 over R total, the reciprocal of it is R total. You have to write the reciprocal of 5 over 30, which is 30 over 5. So the R total here is 6 ohm. Now, is it clear?
Yes, teacher.
Yes.
Now I want to ask you a question. In which case you will get the total resistance greater, in series or in parallel? Look at here. Here we have 15 and 15 and 30. You are connected them in parallel. And in the first case, you have the same resistance, 15, 5, or 15, 15, and 30. Which one give you the greater total resistance if are connected in series or in parallel?
In series.
In series. Thank you.
Series.
So why? Because if you add, in other words, if you have them like this, if you have to find the R total here, we have to say 1 over R total is 1 over 2 plus 1 over 2 plus 1 over 2. So they are 3 over 2. So the R total, 1 over R total here is a 3 over 2. So the R total is 2 over 3. Look at the second case. If they are in series, the R total will be R1 plus R2 plus R3. So the R total here is 6. So that's mean if you connected the series and the resistance and the resistors in parallel, you will get a less total resistance than in series. So the series, if you connected the resistance in parallel, in series, you will get greater total than if they are in parallel. So the series, if one item in the circuit is broken, there's no charge will move through the circuit because there's only one path. But in parallel, if one of the items in the circuit is broken, then no charge will move through the other path. But the other paths will continue to have charge flow through them. As we say, in the series, if one item is not working, all the other will not work. In parallel, If one item is not working, sorry, it didn't affect the other items. And why? Because in the series you have only one path. If it is open, it will let all the lamps working. If it is not, it's not let any of them working. In parallel, if one of the door of the switches are closed, it didn't affect the other switches. Now, in resistance, in series, sorry, as more resistors are added, this is inshallah in the next period we will talk about it, the overall current will be decreased. But on the parallel, as the number of resistors increases, the whole current increased. This is inshallah, we will discuss it next lesson. So today just we talked about the difference between the parallel and the series. In the next, inshallah on the next lessons, we are going to solve more questions, how to find the current in series, how to find the current in the other in parallel circuit, and how to find, sometimes we have a combination of parallel and series, how we deal with them, how we can solve to find the current in each term. Do you have any questions?